Hello, my name is Brett Formosa, and welcome to a Unity tutorial video series for beginners. For this series, I will go through each step with the mindset that all you've done is install Unity with no prior research or experience to make sure everyone can feel included and learn as we go. You can contact me either through the comment section down below, by visiting my personal website, or by leaving a message on my itch.io page. The links are in the description of this video. Last video, we imported some assets into the Unity project, such as a sprite, a font, as well as an audio file. In this video, we are going to implement that audio file that we imported to the game so there is some audio feedback for the player which enhances play instead of hearing nothing. Let's get started with part 10. If we go into the game scene and click on the main camera game object, we will see a component that we can't change anything, which is called audio listener. What this is where the audio from any game objects will be feeding into. If you want to add more spatial sounds, for example, you can put an audio listener on a player game object, which can add balancing, such as feeding audio in the left or right ear to have a more immersive effect. However, we don't need this type of audio for this game. Keep in mind that you can only have one active audio listener at a time in one scene. This makes sense as you only need one active place for the audio to feed into for the player to hear. You can make complex code that turns off the audio listener in one game object and turn it on in another game object, however, as with pretty much any component. We have our audio listener, however, we don't have a game object that has an audio source component. The only thing that is really going to be making sound in the game is our player game object. We will have an audio sound that will increase in pitch as the player gets towards the top of the screen. Let's go to our player game object now and add an audio source component. Audio source components have a handful of options that we can change. The first is audio clip. Audio clip is quite literally the source audio file that you want to be played. You can leave this blank and have it fill with code, however, if you have an audio file that you want to be played throughout the entire time without it needing to change. You can just keep an audio file in the box as well as it'll just use that one audio file unless you change it. Output is just what audio mixer you have attached to the audio source. I won't get into audio mixers in this series, however, audio mixers are great to add audio effects such as echoes if the player is in a cave, or adding more complex audio with proper balancing. I highly recommend adding audio mixers into your games if it has more than a couple audio elements. Mute does just that, silences the audio. Bypass effects, bypass listener effect, and bypass reverb zones ignores any effects that are attached through the listener that you add or any effects in general. Play on awake means that the audio will start once the scene is loaded and won't wait for a trigger to happen through code. Loop just loops the audio file. This is good for background music, for example, unless you want the audio to play once and be silent until the player reactivates the audio source. Priority is how important the audio is to the game scene, which Unity will try to play over any other audio source. Volume is the volume of which the audio file is being played. I always recommend starting with a lower value instead of just the base default value, especially if you don't have a volume slider, as a lot of sounds can be extremely loud and startling, especially when coming from silence. Stereo pan is what side of the ear you want to prioritize the player to hear the audio coming from if they have a stereo setup, which is two or more speakers. The left side will be the left ear of the slider, and the right side of the slider is prioritizing the right ear. Spatial blend brings the audio from 2D to 3D. If you have a 3D game, you may want the audio to be more spatial instead of flat by changing the slider from 2D to 3D. Bear in mind as well, you can make a 2D game work with even 2.5D or 3D sound. For example, having a stealth game where the player needs to listen to the footsteps of patrolling enemies, it makes it easier for the player to track the movements through 3D sound versus 2D sound. Reverb zone mix is if you have a reverb zone on the map or your level, which will add the reverb effect. This option is how much you want that audio source to be affected by the reverb zone. The 3D sound settings I won't get into too much detail. However, there are options for how the audio will sound if you have the spatial blend more towards the 3D option. These options can change if you want a Doppler effect, how the sound will increase based on the distance from the audio listener to the audio source, and so on. With the audio source component broken down, as always, if you want me to explain something more or go over something in more detail, let me know in the comments below and I'll do my best to explain further or create a more in-depth video about it in the future. As mentioned earlier in the video, we want to add an engine sound effect to the player game object. Let's open up the player movement script since we will be using that to manipulate the audio source component through the movement. After this, we are going to add a private audio source, player audio source variable, which we will get the script to automatically grab the audio source component instead of having us drag and drop the component into the inspector fields. Go to the awake function, and in the function, let's add player audio source equals get component, and then in the arrow brackets, audio source, and then parentheses. Doing this, upon the awake function being called, the script will automatically grab the audio source on the player game object. We want to now change the audio source based on the distance the player is from the top of the screen to the bottom of the screen, so we need a few lines of code to implement this. Let's create a new public void engine pitch function to keep things clean. In this, let's add the following code. Float y position equals this dot transform dot position dot y. What this line does is it will grab the current value of the player game object's y value. The next line is float pitch percentage equals math f dot inverse lerp, and then in parentheses min y, max y, and y position. This line takes a minimum y value and a maximum y value and converts the minimum to 0% and maximum to 100%, and it takes the current y position and changes the current percentage of the pitch based on that current value. After this, we will add float pitch equals math f dot lerp, and then in parentheses, max pitch, min pitch, and pitch percentage. This line does the same as above, but instead of y value, it is the pitch values we add in, so the audio will sound like how we want it to sound. Make note, however, for my audio file, the min and max pitch are in the negatives. If you want your pitch to be a positive number versus two negative numbers, you will want math f.lerp min pitch, max pitch, pitch percentage instead of what I have written. The last line is player audio source dot pitch equals pitch, which will be the final step in all the calculations where the pitch will change to the precise amount of pitch we want for the player is on the screen. Next, we want to go to the update function and add engine pitch to the update, so we are constantly changing the audio source component as needed. This may be very convoluted and hard to understand, so as always, if there is anything you want me to go more in depth with, please let me know in the comments below. I will respond as best as I can, or if I need to make a new video focusing on this with different scenarios, I can also do so. To continue on, you'll notice there are 4 variables that are underlined. We just need to add them now to the top of the script for us to fill in when we get the proper numbers. Let's add the following variables now, but let's put them at the top of the script so they are easy to find. Public float min y, public float max y, public float min pitch, and lastly, public float max pitch. Let's save this and jump back into the Unity editor and finish the setup for the audio. Depending on your resolution or size of the camera and your audio file for your engine, our variables may be slightly different, so keep that in mind while we go over the next steps. We need to set our min y variable, so on the goal respawn, let's take the y value from this game object and fill that as the min y value for the player movement script. The max y value will be the top collider's y value. Now, the min pitch and the max pitch will be whatever we think works best for us, so let's add the engine audio file into the audio clip box of the audio source component for the player. Then let's also make sure the play on awake and the loop boxes are checked. Let's also change the volume to 0.25 for now to make sure we don't hurt our ears when we hit play. Once we hit play, find the lowest pitch value that sounds good for you, and also the highest pitch value that sounds good for you. For me, I find -3 is perfect for my minimum pitch, and -1 is perfect for my maximum pitch. Once this is done, let's hit play and make sure everything works. It seems to work perfect. With this, we have now added audio implementation in our game, which is the goal for this video. So as always, I'm going to end it here. In the next video, we are going to finalize the game by building it and then uploading the game to itch.io. Until then, take care, and I will see you in the next video.